The first part of this chapter is about linear regression. You have never heard of linear regression before. We need to know how to do it on the calculator. So make sure that you have your graphing calculator today. I'm going to guide you through that process. Today's lesson is a very, very long one. It's actually a 2-day lesson. You're not going to have any new homework tonight. All right. One of the few days throughout the whole year that you won't have algebra homework because the lesson takes so long. All right. So anyway, if we take a look at this line graph, all right, a bank account starts off with $100. Bob saves $5 per week. All right. When we go to graph that data would be a line graph like we have here. Notice that our y-intercept, all right, this would be our y-intercept right here. Our y-intercept starts off at the y-axis, all right? This would be your y-axis. This would be your x-axis. So our y-intercept, it starts off right here at 100. Notice the little zigzag here, all right? Anytime that you see that on a graph, that is actually a break on the graph, all right? That break on the graph, just so that we don't have to put the numbers in between 0 and 100. All right, maybe after that we start counting by fives, for example. That's what we'd be doing here probably. So we would have 105 and then 110 and then 115 and so on and so forth. Notice that we have weeks along the bottom. All right, that would be the label of our graph is weeks. And this would be money along the side. So one of the things that you're going to have to do is you are going to have to use the graph to make predictions of future data. All right. So we might want to predict what week 9 is, for example. They show you up to week 8. All right. They show you up to week 8, but maybe we want to make a prediction of week 9 for the data. Now, yes, you could figure it out. This one's pretty simple. All right. Because you're adding $5 a week. But there's other more complicated questions that you could have. This data that we graphed here is very linear, right? It forms a straight line. It's linear because we are adding the same amount each week, all right? So that's what makes it linear. This line would be what's called a trend line or a line of best fit, all right? This is a trend line or a line of best fit. They use those two terms interchangeably, trend line and line of best fit. So the data was actually a scatter plot, all right? The data was actually a scatter plot. And so this trend line or line of best fit, which is this red line going right up through the middle, forms that straight line. Unfortunately, data in the real world is not always linear, all right? Data in the real world, you might have a dot here and a dot here and one up here and maybe one over here and one over here. Data in the real world is not linear, all right? Data in the real world can be all over the place, all right? But we're looking at the general trends or the general directions of the data, especially in this first part of the chapter. What we're actually going to find here is we're going to find the equation of this trend line. All right, that equation of the trend line is through our regression equation. Well, when we have our regression equation, we're going to form a straight line with it. So we're going to have the f of x equals mx plus b. When you go to graph a normal line, all right, when you go to graph a normal line, your slope, all right, the pitch of the graph, all right, the direction that it's going, your slope is your m. That's the number that goes in front of your x. Your x is always there. And then your b value is your y-intercept. All right, your b value is your y-intercept. So given a line, you need to find the equation of the line, all right? And our calculator will help us do this, all right? So there are some things that you have to memorize in this chapter, all right? There are some things that you have to memorize. So a linear regression, you're going to work backwards to find an equation that models the data. The regression equation is what I have here. I wrote it on the previous slide as well. The f of x equals mx plus b, and it's obtained by doing the regression. I'm going to show you how to do that on the calculator today. The correlation coefficient. Now, correlation coefficient is the same exact word as R value. All right, your R value or correlation coefficient, those are synonymous for each other. The closer the value is to 1 or -1, the more closely the data fits the equations. The more closely it's going to form a straight line. You're going to see graphs that look like these, all right, with our scatter plots. A scatter plot, these are all examples of scatter plots, by the way. Scatter plots have dots all over the place, all right, just like these do. So when we go to look at that, the R value is always in between -1 and 1. All right, your R value. The calculator will calculate that R value for you. Now, let's take a look at what happens when it falls in between -1 and +1. Well, if it has an R value, if it has an R value of -1, all right, the R value of -1 means that it's going to have a negative slope, which means that the line as you go from left to right will be going down. Remember, slope is your M. That's the value that's in front of your X, all right, in the if in the y equals mx plus b or f of x equals mx plus b. The M is your slope, all right? That's how the line is pitched. So if it has an R value of -1, it's going to be going down. If it has an R value of positive, your slope is going up. And notice that all of our negatives, all right, all of our negatives, the general trend of the data as you go from left to right is going down. This is going down almost in a straight line right here when it's at -1. But as we get closer and closer to 0, notice that our dots are spreading out a little bit. All right, our dots are getting a little bit farther away. You can still tell that the general trend of the data is that it's going down, but our dots are a little bit more spread out. As we get closer and closer to 0, our dots spread out even more. You can tell just by looking at these dots, though, the general trend of this data is that the dots are still going down. All right. When your R value is 0, there is no relationship. The dots are scattered all over the place. You can't tell if your dots are going up or if the dots are going down. Those dots are all over the place when it has an R value of 0. Now, as we get closer and closer to 1, now our dots are going to start going up again. If you look at this scatter plot, the one that has the 0.3, we can tell that the general trend of the data is that the dots are going up, all right, as we go from left to right. Anytime that you look at a graph, you always go from left to right, just like you're reading a sentence. So the general trend of our data is going up. As we get closer and closer to 1, notice that our dots are getting tighter, closer together. All right, our dots are getting closer and closer together to almost start forming more of a line. They have a stronger relationship to each other. And then when we get to exactly 1, notice that it forms a straight line again. All right, notice that it forms a straight line. So we have a straight line of data at -1 and at +1. At 0, the data is all over the place. You can't tell if it's going up or if it's going down. As we get closer and closer to the 1 and the -1, that becomes a stronger and stronger relationship. So that gets closer and closer to forming a straight line. As we get closer and closer to 0, the points spread out more. All right. If your R value is negative, it's going down. If our R value is positive, it is going up. And it can be anywhere in between there. All right. It can be anywhere in between there. But negative means that it's going down. Positive means that it's going up as we go from right to left, just like, as we go from left to right, just like we read a sentence. 0, there is no relationship. Now, interpreting your correlation coefficient or R value. If it is in between a 0.7 and 1. Now, notice this symbol right here. It might be a symbol that you've never seen before. You have a positive sign on top of a negative sign. How that's read is plus or minus. That's how it's read, is plus or minus. So we're talking about a positive 0.7 to a positive 1, and we're talking a negative 0.7 to a negative 1. So if it's in between here, all right, if it's anywhere in between here from the negative 0.7 to the negative 1, or if it's in between here, the 0.7 to the 1, that represents a strong relationship. That means the dots are very close together. They're very closely related. That represents a strong relationship. As we get from 0.3 to 0.69, it gets moderate. Moderate means that it's in the middle, all right? Some of the points are good, they're closely together, but other ones are a little bit wider apart, all right? But it's still a pretty decent relationship. It's sort of in the middle, all right? So green would fall in here, all right? And green would fall in here. And again, these are just examples here, so they're not perfectly matched with these numbers. Then we get closer and closer to the middle. As we get closer and closer to the middle, there is no relationship at exactly 0, but the other ones in between there, all right, in between there are weak relationships. So strong relationships form more of a line. Middle or moderate relationships, you can still see the general trend of the line, but it's not a perfectly straight line. And then as we get closer and closer to that middle, no relationship, the dots get farther and farther and farther apart. All right. And this will make more sense when we actually start doing questions. All right. Here's just another way to sort of look at it. We have from our 1 to our negative 1, or negative 1 to 1. Notice that here's our negative 1 and 1. That represents the strong, all right? Then as we get into the middle, this is moderate here in the middle. And then we have our weak at 0, all right? And just to the left and just to the right of it. So it's sort of coming together in the middle where there is no relationship. So again, negative goes down, positive goes up, 0, there is no relationship at all. All right. So this is a very, very important slide. This is in your it's in your Schoology folder today and in the folder of the notes. All right, these same diagrams. You'll probably be referring back to these a lot, especially this table down here. All right, because you're going to have to calculate the R value or correlation coefficient. And then actually part of your homework says, is it a strong, moderate, or weak relationship? All right, so you're going to have to do that. You're also going to have to say if it's positive or if it's negative. It's negative if your R value is negative. It's positive if your R value is positive. All right. Questions about this slide right here? Any questions about this slide right here? So we had a question that asked, what does mx plus b stand for? Mx plus b, you're going to have to find the equation of the line. In the equation of the line, the m stands for your slope and your b is your y-intercept. And that'll make sense once we start doing more questions. We will be using the calculator to find your R value. So in your calculator right now, all right, get out your graphing calculator. So we are going to type this chart into our calculator. All right, we're going to type this chart into our calculator. The first column is going to be your L1 column. Your second column is going to be your L2 column. All right. So we're looking at games, and at 6 different games, there is attendance taken. All right, at 6 different games. Maybe it's a baseball game or something like that, minor league baseball game. So we have 6 different games and we have attendance. Now, where we're going to type these numbers into, and I'm going to have to bounce back and forth from the calculator. So this is going to become a sort of a pain in the butt a little bit. So when we're bouncing back and forth in the calculator, so in the calculator, first of all, when you open up your calculator, clear the memory, please. All right. So hit second plus 712, second plus 712 to clear your memory on your calculator. That way we can start fresh and anything that's in there will get cleared. Second plus 712. So we're going to be using the stat, and these step-by-step directions are right in the notes also that are in your Schoology folders. So first of all, to enter data, all right, we are going to use this stat button. It's right next to the keypad. We're going to use the stat button. When we click the stat button, we want to be able to type in edit. All right, we want to type in data. So it's already on number 1, which is what we want. So just hit enter. This is what I was talking about with your different columns. All right, you can type in lots of different data all at once. We're going to type this stuff in. So our games were 1 through 6. So all that you're going to do is type in 1 and hit enter, type in 2 and hit enter, type in 3 and hit enter, type in 4, 5, and 6. So we're typing in our games from our table in our question into the L1. Now we want to type in the attendance for each of those games into our L2 column. Well, to get to your L2 column, we can just use the little arrow pad and just use the right arrow on your arrow pad to get into your L2. So the first attendance for game 1 was 2,000 people. So we're typing in 2,000. Then we have 2,132. We have 2,198. 2,301. 2,285. And 2,401. So if you could type in that data, please. I'm going to tell you that one of the biggest mistakes that people make is accidentally typing in the data incorrectly. All right, it's very easy to accidentally do something. So anytime that you type in your data into your L1 and your L2 columns, always go back through and double check your data. It's very easy to type something wrong. And if you even have one number wrong, it will screw up the entire question. All right, even if you're off by one little number. So again, if you didn't get that, we went to stat and then edit. All right, stat and edit to type into our L1 and our L2 column. So now we can see a graph of this data. All right, to see a scatter plot, which is like a dot plot type thing, to see a scatter plot of this data. All right, what we're going to do, if you look above the y equals, all right, if you look above the y equals, it says stat plot. So we want to do a stat plot. So we're going to hit the second button and then hit your y equals button, which is really stat plot. So second and y equals. When you hit second and y equals, which is stat plot, it turns up with this screen. What you're going to do is we want to turn the stat plot on. So in order to turn the stat plot on, you're going to hit enter. We can do different types of scatter plots where we want this first type of scatter plot. So now see how this cursor is blinking right here on the on? Right now it's set to off. We need to turn it on. So we need to hit enter right there. And now notice that our on is now highlighted. So we turn the stat plot on. Now what we want to do is we want to graph it. So we're going to hit zoom. Zoom is in the top upper middle. And now we want to go down to number 9, which is zoom stat. We want to go down to zoom stat. And then hit enter. You should get this graph. So this is a graph of our data. This is a scatter plot of our data of the attendance. So think inside your head right now. Would this be a positive correlation or a negative correlation? Would this be a positive correlation or a negative correlation? As we go from left to right, our data is clearly going up. All right, going from left to right, it's clearly going up. Unfortunately, I can't write on the screen. But as we go from left to right, it is going up. So this would be a positive correlation. Do you think it looks pretty close together? Do you think the dots look pretty close together? I think they do. All right. I think this represents a pretty strong correlation. All right. Remember, when we go to look at strong and weak correlations, all right, we want, I hit the wrong button. We want to look and see, all right, when we look at strong and weak correlations, a strong positive, this would be a strong positive right here. It forms almost a straight line and it's going up, going from left to right. It wouldn't be negative because negative goes down. When we look at our calculator, notice going from left to right, our data is going up. All right, our data is going up and those dots are pretty compacted. It's almost forming a straight line right there. So I know that this would be a strong positive correlation. This would be a strong positive. Well, now we can use the calculator and actually check and see what it actually is. One of the most important buttons that you're going to need to do is you're going to need to turn on your stat diagnostics. All right. Now, where do you find your stat diagnostics? That is by hitting the mode button. Right next to the second button is your mode button. The mode button, when you press it, looks like this. There are all types of settings that you can change and adjust and things like that. Stat diagnostics is almost all the way down to the bottom. It's right here. If you could see my mouse, it's right here. We want to turn the stat diagnostics on. So what you're going to do is you're going to use your arrow pad and keep on going down to your stat diagnostics. You can see that now when I went down, my off is blinking. Well, I don't want it off. I want it on. So I'm going to use the arrow pad again and go over to the right and hit enter. That just turned my stat diagnostics on. So I went to mode. I used the arrow pad to go down to stat diagnostics, and then I went to the right and turned it on by hitting enter. So now that I have my stat diagnostics on, I'm going to go back to stat. All right, I'm going to go back to stat, which is right next to the arrow pad. We want to do some calculations now. So where edit, stat and edit allowed us to type in our data, stat and calc in the middle is going to allow us to do our calculations. So we're going to use the arrow pad again to go to calc. All right, we went from edit to calc by using the right arrow pad. And now here's a sort of confusing part. There looks like there's two different things to do linear regression. We want this number 4, 1. Notice how it has ax plus b. That a is going to be our slope because our slope is our number that comes in front of our x. And our b is going to be our y-intercept. So we want to go down to number 4. You're always going to use number 4. We're eventually going to do quadratic regressions and things like that where we'll use like number 5. And we'll use number 1 variable statistics and 2 variable statistics. But right now, all that we're doing is linear regression. So we want number 4. So we're going to go down to number 4. and hit enter. Go down to number 4 and hit enter. It looks like there's nothing here, but there actually is. The calculator is asking you, it's saying, do you want to use the data in L1? Yes, we do. It's asking you, do you want to use the data in L2? Yes, we do. You can actually, in your stat and edit, you can type in lots of other data and you could choose to use different columns if you wanted to. But the calculator right now is asking you, do you want to use L1 and L2? Yes, we do. And so we want to go down using your cursor, all right, using your arrow pad, go down to calculate. All right, go down to calculate and hit enter. And it looks like it's working and it comes up with this screen. All right, it comes up with this screen. This screen is where you're getting your R value from. All right, this screen is where you're getting your R value from. So when you look at your screen right now, you have a couple different numbers. First of all, here's our equation. All right, here's our equation for our line. Our equation says y equals ax plus b. A is your slope. So this is the number that really technically goes in front of your x. Now, those are really, really big, long decimals. You are going to want to round to whatever your data's decimal point is, all right? If it's not specifically said. Sometimes it'll say round to the nearest 10th or round to the nearest 100th or something like that. If it doesn't say what to round to, what you want to do is you want to round to whatever your data looks like. Well, what the heck does our data look like? Our data was all whole numbers. Our data was rounded to the nearest ones place, all right, or a whole number. So we're actually going to round our A equals to 73, all right? We're going to round this to be 73. Our B is our y-intercept. This would round to 1,963. R squared. R squared, we're just going to ignore our R squared value. That's not what we're going to use for linear regressions. This is sort of extra data that you don't need. We don't want our R squared value. Our R value, or our correlation coefficient, this is our R. So our R value or correlation coefficient is 0.96939, blah, 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 blah. With the R value, R values, you're not going to round to your data's value decimal place. All right. Normally with an R value, most of the time, and it varies per problem. But most of the time you're safe just going to like 2 decimal places. So if we had like an R value of 0.97, all right. Notice that our R value is positive. If your R value is negative, you would see a negative sign in front of this 0 right here. But remember, negative goes down, positive goes up. So this has an R value of 0.97 approximately. All right, now 0.97 would fall, 0.97 would fall into this where it would be strong. All right, and 0.97 would definitely be very, very close to 1. And so that's saying that the data is forming a straight line going up. All right, that's 0.97. So that's really, really close. When you go to do your equation, all right, when you go to do your equation, we're a couple slides ahead of this now. When you go to do your equation, you would get this down here at the bottom. All right, this is what we got on the calculator screen. All right, this is what we got on the calculator screen. And so the 73 would be your rate of change or your slope, which is your M. The 1,963 is your y-intercept. Remember, you're ignoring that R squared. We don't care about that R squared. And then your R value is this. So what you're going to do with that A and your B value is that you're going to form an equation. All right. The generic form for the equation of a line is y equals mx plus b. This m is your A. All right. That's the number that goes in front of the x. So from our data, we're going to have 73x. And our y-intercept is our plus b, which is that 1,963. This is your regression equation. This is your line of best fit or trend line. So now what we're going to do is we're going to go back to the calculator. We're going to go back to the calculator and we are going to graph that line in the calculator. So when we go back to that line, all right, our equation, we're going to go to y equals, and now we're going to type in that equation into our y equals. So our linear regression, our line of best fit was 73x. Remember, the x button is right next to your alpha button, plus 1,963. So that is our line of best fit or trend line. All right, that is our line of best fit or trend line. So when you go to graph that, all right, we can just hit graph now. And notice that it put that line of best fit or trend line right in the middle of all our dots. That's what the line of best fit or trend line actually does. It puts it right in the middle of all of our data. It makes the best line possible. I'm touching the screen like you can see the screen. You can put the line of best fit goes right through the middle of all of the data. If we go back to my notes for a second, all right, if we go back to the notes, the line of sorry. If we go back to the notes, the line of best fit or trend line is sort of what I drew right here with my lines. These are all the line of best fits or trend lines. They go right up through the middle of the data. About half the dots are above the data. About half the dots are below the data. We're trying to find the middle of the data, all right, where about half the data is above it and half the data is below it, all right? So this would be our line of best fit or our trend line. When they do form a straight line, the line of best fit would be right on that trend line, right along that same line, because the dots would line up perfectly when it's a -1 or a +1. So, whoops. So when I go back to the question here, all right, when I go back to the question, this was our data. All right, this was our data. Hopefully you can see my screen. We're going to use the linear regression equations to make predictions. So our equation was y equals 73x. This is what we got from our linear regression, plus 1,963. That was our linear regression equation. We're going to make a prediction about the data. That is called extrapolating. All right, that is called extrapolating the data. It's making a prediction outside of the data that you're given. So if we are going to make a prediction for game 9, all right, if we were going to make a prediction for game 9, for example, what you would have to do to extrapolate the data is to take this 9 and put it in here for x. All right, so if we sub it in there for x, we're going to have 73 times 9 plus 1,963. When we do that, we get 2,620 when we do that calculation. So for game 9, if we kept on using this data, our best guess based on our trend line or line of best fit is that game 9 would have 2,620 people. And again, where we're getting that from, we could also use the calculator to make that prediction, right? By going to second and table, just like you did in the last chapter. If we hit second and table and we go down to 9, notice that for our line, which is a prediction of our data, we have 2,620. That's the same thing that we got by subbing it back in to the into the equation. All right. Questions about anything so far? I know this is probably super, super overwhelming. Tomorrow we are going to do more and more of these. All right. And we will pick up right here. All right, where we left off. Yep, that's fine. So we are going to start right from here tomorrow. There is no new homework tonight. However, I would strongly encourage you go back into school tool, go back into school tool, look and see what you owe me and do your makeup work. All right. Do your makeup work, please. We are starting a new chapter today. All right. This is the chapter that we are doing for the next 2 weeks. It's very important that you stay on time with your homework assignments, but we'll pick up right here tomorrow. So, unless you have any questions, you are free to go.